In Chapter 12.2, we're still discussing how to organize data sets into tables and graphs. In Part 2, we're going to be talking about quantitative variables. Our major objective in this section is to organize quantitative data into tables and graphs. Our objectives are to construct frequency distributions for quantitative data, construct histograms, and determine the shape of a distribution from a histogram. So typically, if we have a data set, we will put the data set in a table first. And the data set that we're looking at is variables that have measurements to them. So for example, in this particular frequency table, we're looking at the BMI of females of a particular statistical class. So the first idea is first to create a class interval. So we're going to talk about how to create a class interval first. To do this, we look at, in the data set, we look at the minimum value and the maximum value within the class in the data set. And then we subtract that and we call that the range. So the range is equal to the maximum value minus the minimum value of the data set. The second idea here, the second step is we determine the number of classes. This number has got to be greater than 5 but less than 20. And this is the number that usually we play around with to get the right number of classes so we can see the proper distribution. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8 classes that we're going to have. But again, it depends upon your data set. Once we determine the range, we will divide the number of classes into the range, and that will give us what we call the class interval size. In this case, the class interval size is 3. And you say, well, why is it 3? Well, because between 17 and 20 is 3 spaces. In other words, everything in BMI that has a decimal point will go up to 19.9 in this row. So once we divide, we do step 3, we divide the number in step 2 by the range value and round up. This is your class interval size. We set up the class intervals by equal number values from the minimum value based on the class interval size. So in this case, the interval size is 3, so we start out 17, 20, 23, 26, 29, 32, 35, and 38. And then, of course, we complete, that's called this is the lower bound of the class interval, and this is the upper bound of the class interval. And so, obviously, if the next number is 20, the number below it is 19. Okay? Once we have the class intervals, we then count the number of students, in this case, that have the BMI within the class interval range. And so in this case, there was 2 students that had a BMI between 17 and 19. There was 8 that had a BMI between 20 and 22, and so on. So the final idea here is to calculate a midpoint of the class interval. The book says to add the upper bound to the lower bound and divide by 2. Other books show that you add the next class number, 20 to 17, and divide by 2. And that happens to be the case in this particular example. We added 20 to 17 divided by 2. It got me 18.5. We added 20 to 23 and divided by 2, and we got 21, and so forth. In the book's value, 18 would have been the midpoint here, and 21 would be the midpoint here, 24 would be the midpoint here, and so forth. Once we have the frequency table, we now can produce the histogram. So in this particular case, we have a scale, and usually the scale can either be on an interval size. This is X, and this is going to be BMI. And over here on this side is frequency, and this is BMI for females. And I believe this was 2016. Now what we don't have here is our scale, and so if we go back to the previous page, we started out with 18, we went up 3 to 21, we went up 3 to 24, I believe, and 27, 30, 33, 36, and 39 was the midpoints. And then on the frequency side, remember, this here was 1, this was 2, 3, 4, 5, 6, 7, 8, and then we would want to have 9 up there. So, from our frequency chart, midpoints was calculated for each class. The x-axis of the histogram is the midpoints from each class interval. The y-axis is the frequency of each class interval. And the histogram provides a picture of the center and the spread of the variables data set. So in this particular case, you see the most frequent of the BMIs is between 20 and 21, right? There's also a small number of BMIs at the higher range, 30 to 36, that are also kind of showing up in the data set. So it looks like the data set is kind of binomial in some sense, and that may be because of age. There may be an age factor that's also related to BMI in this table, and you can maybe see that with the two distinct groups. So the histogram gives us the features of the data set for a particular variable. So typically we're interested in the shape of the histogram. If we have a histogram that is symmetric, we see kind of what we call a bell-shaped curve, and in most cases that's a good thing because it means that our data set is approximately normal. There's also another way that symmetrics can happen is if it's a uniform distribution, and we'll talk about that later on in class. We can also have the shape of a histogram where we start out kind of high of our data values and we go down. And this is skewed to the right. The data is skewed to the right because the lower values are to the right, where the maximum values of the frequency is to the left. Both these particular distributions are called unimodal because they have one bar that's higher than any of the other bars. So here are the different features of our quantitative variables that can show up in our histograms. You can see that the first one looks really kind of symmetric. It looks almost normal, so we call that a symmetric distribution. Here, the data set is kind of skewed right. Here the data is skewed left because the small data set is over here to the left side, where the large frequency numbers are to the right. And then again, if we have two major points of interest, like here, this is called unimodal. In other words, there's one bar that kind of stands out among others. And then this can be considered here as a bimodal histogram. In bimodal histograms, typically there may be another variable that has an impact on the data set. One example would be if we were plotting both female and male heights in the same graph, you would see a bimodal histogram. Well, that concludes our part 2 of quantitative variables, of setting up a table and a graph. In the next section, we're going to talk about more graphs and more plots and other ways of organizing quantitative data.